This video is over lesson 107, graphing absolute value functions. So ladies and gentlemen, remember that a parent function is your function without all the extra addition and subtraction, multiplication, division. It's just the basics of it. So if we're talking about an absolute value function, the parent function is just going to be the absolute value of x. And so that tells us a few things when we take a look at that. And we're going to make a sketch real quick here of a graph of this. So a sketch means that we're not going to necessarily put in all the numbers and everything. We just want to see the shape of it. So an absolute value function, remember absolute value means the distance from 0. So if we consider how far is 1 from 0, well, it's 1 away from 0. 2 is 2 away from 0. 3 is 3 away from 0. 4 is 4 away from 0. 5 is 5 away from 0, and on and on and on. So what we're going to see here is that this goes out at about a 45, well, exactly a 45-degree angle. So do your best to make a 45-degree angle there, because you're going to have the points 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and on and on and on and on. Now on the other side, though, negative 1's distance from 0 is positive 1. Negative 2's distance from 0 is positive 2. Negative 3's distance from 0 is positive 3, and so on and so on and so on. So what's going to happen here, though, is instead of having negative 1 comma negative 1, negative 2 comma negative 2, you're going to have negative 1 comma 1, negative 2 comma 2, negative 3 comma 3. And so you're going to get another 45-degree angle. Going out that way. And so what we see here is that absolute value functions, their graphs form a V. And there's a couple of particulars about the V that I want you to understand. First of all, this side of the V is a ray, so it's a part of a line. And the slope of the parent function on this side is 1. On the other side, the slope is a negative 1. So to the right, we have a slope of 1. To the left, we have a slope of negative 1. Now, since this forms a V, this means that there's a corner point here, and the corner point is called, the vertex. Now, this is the really basic absolute value. From here, we start to modify the equation. We start adding and subtracting things. We start multiplying things. And so what we end up with is a slightly more complicated absolute value function. And these can really get quite complicated depending on what we put in here. But we're going to keep things pretty much linear right now. So we're not going to dive too deeply in. But I want to take a look now at modifying it. So we have A times the absolute value of x minus h plus k. So that's going to be kind of our standard form, if you will. It's not technically standard form, but it's basically going to be our standard form for what we're going to be doing with this lesson. So what we've got here is we've got something being subtracted with x, then something added with the absolute value, and something being multiplied with the absolute value. And so A, H, and K each do something to the shape of this graph, the shape or the position of this graph. Now H is the horizontal translation. Remember that translation just means you're sliding it. So H is how far you're sliding it left or right. Now remember that when you see a minus in the formula, you've got to think of this as subtraction. So if this says minus 2, it means that it's actually a positive 2 translation, which means it would move it 2 to the right. If it said plus 3, well then you got to think about it as minus. So plus 3 would really be minus negative 3, so it would be a negative 3 horizontal translation, so 3 to the left. Or an easier way to think about it is because the formula says minus, whatever you see here, it'll actually be the opposite of what you see. So if you see -2, you think -2. No, it's actually going to be a +2. If you see a +3, that looks like +3. No, it's going to be a -3. On the outside here, we've got K, and K is the vertical translation. So how far it's pushing our graph up or down. Now, since the formula says plus, what you see is what you get. If this says +2, yeah, it's really going up 2. If it says -3, yeah, it's really going down 3. And finally, that leaves A. And A does a few things for us. First of all, A tells us is if this is opening up or down. A can also stretch or compress our graph. And so we're going to focus in on what happens with A in particular here in a few different ways. So we're going to make a little chart. Let's just make it, we'll take up 6 lines. That should be good enough. Or apparently we'll take up 5 lines. I must have counted one of my lines twice. It doesn't really matter. If you did 6, that's fine. I accidentally did 5. Not a big deal. So there's a few things that we need to look at. So first of all, up or down. If A is greater than 0, then my graph is going to open up, just like our parabolas would open up. If A is less than 0, our graph will open down, just like our parabolas opened down. So in that way, this is similar to our quadratic functions. Now, where this is different, though, at least a little bit different, is that we are also going to be taking a look at the absolute value of A itself. Now, it's not in the absolute value, but if the absolute value of A is greater than 1, the absolute value of A is greater than 1. So what this is basically doing for us is it's saying as long as you are more than 1 away from 0, doesn't matter if it's positive or negative. And if you think about multiplication, whether it's positive or negative isn't going to really have anything to do with the value. It'll just have to do with the direction things are going at the end. So if you think about numbers that are greater than 1, when we multiply by them, the result is greater than what we started with. So this is going to result in values that are either further positive than we started with or further negative than we started with. And so what happens here is that my graph is going to be stretched. So that way it will no longer be at that 45. Likewise, if it opens downward, so if it's opening up and that absolute value is greater than 1, it's going to stretch upward more than the parent function would. So if we look at the parent function just going out there gradually, slope of 1, slope of -1, this is going to go out much faster, or going up much faster. Down here, the negative A value is going to flip it down, but the fact that the absolute value is greater than 1, that means that this is actually going to stretch faster down. On the other hand, if the absolute value of A is less than 1, well, first of all, it's going to have to be greater than 0. We don't want A to be 0. And we can only go up to 1. So somewhere between 0 and 1, well, those are all our decimals, all our fractions. And so if you take a decimal of something or a fraction of something, you're taking less of it. And so this will actually result in a compression. And so instead of going up at a 45-degree angle, it's going to be compressed downward. And then if A is negative, same idea, just opening downward instead. So if A is positive, it opens up. If A is negative, it opens down. If the absolute value of A is greater than 1, it stretches. If absolute value of A is less than 1, it compresses. The vertex of the parent function is up here at 0, 0. 0 is the distance of 0 away from itself. But here, if I slide h horizontally and k vertically, my vertex is going to do those as well, meaning that my vertex will now be at h, k. So I'd like you to grab a color now. I don't care what color you choose. I'm happening to choose my green here. And I want to put all this here together. Now let's talk real world for a quick second. So in the real world, A is your rate. A is your rate. Oh, and by the way, we're going to come up here for a quick second. I forgot to mention this. The right side now, instead of being a slope of 1 like the parent function, the slope on the right will be A. The slope on the left will be negative A. And that's actually true for every single one of these. So even over here, to the right, it's A, which since A is negative, that's why it's going down. And then over here, the slope would be negative A, or a negative of a negative, which is why it's a positive slope. So it's always to the right, it's A, to the left, it's negative A. So even if A is negative, that's still the case. So that'll be important in a little bit here. So anyway, back to this. So in the real world, we have a rate. A is the rate. H does a few things. So remember, if you have x minus something in an absolute value, we're no longer measuring the distance from 0, we're now measuring the distance from h. So h is now the number we're measuring the distance from. And it's important to note here too that when we talk about the distance from something, that distance can actually be time, or it can be an actual distance. So it could be a distance in time, or it could be a distance in space. So it doesn't just have to be physical distance, but it could also be distance in time. So along the same lines here, h in the real world can be a point, or sorry, not point, value, sorry, value. A value at which a value at which something turns. It can also be a point at which we change from moving towards something to moving away from it. So for example, if I have a point out here and I'm traveling along, then I would get closer and closer and closer and closer. Now if I decide to turn back at this point, then well, if we were to measure the distance as I moved closer and then chose to turn back, okay, that could be my turning around point. So especially if that's time, what time do I choose to turn around? Okay. If I'm looking at a number line, let's say 0, 1, 2, 3, 4, 5, 6, 7, 2, 4, 6. So let's say the point I'm looking at is 5. So my h is 5. Then we could consider how far am I away from 5? Well, I'm getting closer, 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 0 away from 5, and then further, 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 further. And so that could be my v in my graph. So it's the point at which we change from moving towards to moving away from something. All right, and then K adjusts the minimum or maximum distance. So minimum and maximum, because if we consider if it's opening up, then my vertex is a minimum value. If it's opening downward, my vertex is a maximum value. So since K adjusts that up or down, well, normally an absolute value would have a minimum or maximum of 0. But if I have a K, let's say that's +2, it's going to shift that up 2. So either my minimum distance is now 2 or my maximum distance is now 2. So again, that could be a situation where instead of looking at the time, going back to this example, if my distance is a measurement of time, I choose to turn back at this time and come back this way. But as far as the distance goes, my K could be expressing this distance right here. What's the minimum distance I am away from this thing? So they kind of come together. We'll look at some examples of that. So, ladies and gentlemen, with all this being put in place, let's take a look now at some examples. So I'm going to flip my paper over. I'm kind of out of room. And we're going to look at the practice problems. So the basics of this really are quite simple. So letter A, we're told to graph each function and give the coordinates for the vertex. So f of x equals x absolute value of x plus 2. So real quick here, I just want to think through with you. I want to know what is A, I want to know what is H, and I want to know what is K. So A is the thing multiplied out in front, which means A this time is 1. So we have a rate of 1. That means the right side of my V is going to have a slope of 1. The left side of my V is going to have a slope of negative 1. H is what we're subtracting from x. Well, I don't see anything being subtracted or added with x, which means we're really subtracting 0. And then finally, the thing that we add behind the absolute value, or add with the absolute value, that's our k. So plus k, in this case, plus 2. K is 2. And so from that, right away, I can tell you that the vertex is h comma k. So 0 comma 2. Now if I graph this, let's just go ahead and make a coordinate plane here. I'm going to take up about 4 spaces on my paper. Now I'm going to put tick marks in because now we're not doing a sketch, we're actually doing a graph. So graphs need to be nice and neat, need to have tick marks. And I'm just going to use the half spaces to kind of help me make that nice and even. So we know the vertex is 0 comma 2. So I'm going to come up here to 0 comma 2. And then, because A is 1, I know off to the right that we have a slope of 1. So I'm going to go up 1, right 1, up 1, right 1. Off to the left, I have a slope of negative 1. So that would be down 1, right 1, but that's going the wrong direction, so we got to reverse it. So it's going to be up 1, left 1, up 1, left 1. And so if I draw my V now, there's my graph. So again, this has a slope of A, this has a slope of negative A. And there's my vertex and my graph. Let's take a look at B. So f of x equals the absolute value of x plus 2. So this time my 2 is inside the absolute value. So again, A, H, and K. A again is 1. There's nothing we see there, which means it's really a 1. Now inside the absolute value, we do see a plus 2. If you go back to the formula though, the formula says x minus h. So we've got to think of that as subtraction, or you take the opposite of what this is. So if it says plus 2, it's really a negative 2. K is what's being added outside. Well, there's nothing that we see being added outside, which means it's really a 0. So this time, my vertex is negative 2 comma 0. And now if we graph this, again, I'm going to use the half spaces here to make this as neat as I can. So now my vertex is a negative 2 comma 0. It's right there. And because A is 1, that means that to the right I have a slope of 1. Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So there's the right side of this. And the left side will have a slope of negative 1. So that's going to be up 1, left 1, up 1, and if I put one more tick mark in here, left 1. And there's my graph. And then on to C. Letter C, we have f of x equals the absolute value of x minus 1 plus 2. So now I want to think through things again. So a this time is still a 1. H this time, remember, it's minus h, so it's going to be the opposite of whatever we see, so it looks like a negative 1, means it's really a positive 1. And then k is plus k, so it's exactly what you see. It looks like a positive 2. It is a positive 2, which means that my vertex is 1, 2. So if I go ahead and graph this, so vertex at 1, 2. To the right, my slope is a, so 1, up 1, right 1, up 1, right 1. To the left, it's a negative 1, so up 1, left 1, up 1, left 1. That right there is my graph. D. Describe the graph of each function. So this time it doesn't ask us to actually graph it, just to describe it. So looking at it, we know that since a is greater than 0, it opens up, and since the absolute value of a is greater than 1, it is stretched vertically. E, well, a there is a negative 2, so since a is less than 0, we can say it opens down, or another way to express that is it is reflected across the x-axis. And then since the absolute value of a is greater than 1, it is stretched vertically. F. So in this case, F, our a is a negative 0.5. So first of all, since a is less than 0, it is reflected across the y-axis, or it opens down. Same thing. And since the absolute value of a is less than 1, it is compressed vertically. And then G. Letter G. The distance of a truck to a manhole cover is given by the function f of t equals the absolute value of t plus 25. Write the function representing the distance of a truck starting at the same location, but traveling twice as fast. So ladies and gentlemen, if it's traveling twice as fast, remember that a is our rate in the real world. So right now, a is 1. So if we go twice as fast, a will have to become 2. So the function is simply f of t equals 2 times the absolute value of t plus 25. Now, ladies and gentlemen, if you would, Please take a look at example 5. I want to just talk through example 5 here real quick. So example 5. A helicopter pilot is traveling from town A to town B at 60 miles per hour. To make sure he is on course, he will fly over a landmark that he knows is 20 miles from town A. Write and graph the distance from the landmark as a function of minutes of flight time. So there's a certain number of minutes till he reaches his destination, or at least his landmark. So since he's traveling at 60 miles per hour, that's really 1 mile per minute. And so the way that we're looking at this is if we have a graph of time here, so he's at 0, and then at 20 miles away, and so it'll take him 20 minutes to go 20 miles. At 20 miles away, he's going to hit his landmark. And then he's going to continue past it towards town B. So as he moves, his distance is getting shorter, smaller and smaller and smaller and smaller and smaller and smaller until it's 0. And then it starts getting bigger and bigger and bigger and bigger and bigger and bigger. So if we consider graphing that out, then what's happening here is he's getting closer, 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 closer till he is 0. He's there, but then he flies past it and continues on to town. And so there's our V for our absolute value right there. That's what's going on there. So in this case, 20 then is the thing that we are finding the distance from. In this case, it's a time distance from. And so that's my H. Now, physically, how far are we getting away from that landmark? Well, he's going to fly right over it. And so the fact that I have a Y value of 0 here, that's my K. So it turns out that the minimum distance here is still going to be 0. So we don't, K doesn't really need to change anything there. And then finally, what's the rate at which he's going? Well, since I have a slope here of -1 and a slope here of 1, that means that A must be 1. Which is how the book then put this all together to get the function for the helicopter. So f of x equals 1 times the absolute value of x minus 20 plus 0. Which then if we simplify that, the book actually didn't simplify it all the way. So the function of the position of that helicopter will actually be the absolute value of x minus 20. All right. Well, ladies and gentlemen, I want to bring up one more thing here before we are finished with this lesson. That should help with the homework. And you'll see that I'm pretty much out of space here. I really don't want to go to a new sheet of paper. It's not going to take very long to go over. So I'm going to come up here. If you got room at the bottom, feel free to do it on the bottom. But just something real quick to hit on is something that will help you change absolute values into this form. So sometimes you're going to run across them where they're not in this form and we need to change them. So one of the things that you need to understand is that if you have the absolute value of A times B, the absolute value of A times B, well, you know in the end it's going to change to a positive. So these could both be negatives, in which case, okay, the answer is positive. Just one of them could be a negative. which means that we'll get a negative answer, but then it'll just turn into a positive. They could both be positive, in which case it'll still be positive. So it doesn't really matter if either of them has a negative, it's just in the end going to go away. One way or another, that negative is going to go away. And so it turns out that this is the same as each of these absolute values multiplied separately. So how does this help me? Well, so glad you asked. If we end up in a situation where, let's say, we have a function that is equal to the absolute value of 2/3 x minus 60 plus 5. So in this case, we don't have this in the form like that. We've got something multiplied inside instead of outside. So that means that we are not actually seeing h here. So even though it says minus 60 here, 60 is not my h. Now plus 5 is my k. That's all set. I know what k is, but I don't know what h is. So what we can do here is we can think of this as being the absolute value of 2/3 times, and we have to consider if we were to factor out that 2/3. We're going to factor out that 2/3. What would be left behind? So in other words, 2/3 times what gives me 60? Well, 2/3 of 90. And so then if I actually take the absolute value then, well, 2/3 absolute value is really just 2/3. And so by factoring that 2/3 out and taking its absolute value, we can now see that a is 2/3, but now we can see that h is 90 and k is 5. So this could come up on the homework, and if it does, that would be how you'd handle a problem like that. That, ladies and gentlemen, is the end of this lesson.